So good morning. In this lecture, we'll go through coding and the recap of this session, and then I'll hand over to the person in charge of the next session. So in the last class, we went through some basic Python programming. You understood how to use Google Colab, how to print, that's to display something on the screen, how to comment, that's code for your understanding that will not give an error or compile. You understood variables as well, which was used to store data. We also went through lists, dictionaries, arrays, the import statements, the ask keyword. So remember, import NumPy as NP. NumPy, which stands for Numerical Python, is an open source Python library that's widely used in data science and scientific computing. So we use that to create arrays. And then we went on to data handling with pandas. So for that, we imported pandas, which is a library for data manipulation and analysis. And we made an alias PD for it. So instead of writing pandas.something, we wrote pd.something. So we had this URL here. And remember, with pandas, you can read a CSV file with .read_CSV, and we stored it in a variable that's called data. And we use data.head to display the first 5 rows, and we use data.describe to summarize. So, and then we went on to the Titanic data set as well, data.head. And then the Titanic data set has the following columns. We have passengers survived, class, name, sex, age, siblings, parents, tickets, fare, cabin, embarked, and so on. So with data.describe, you can see the summary of this. So like the number of rows you have. So it can count the number of values you have in each row. It can give you the standard deviation, the mean of each one, and so on. You can also use print.data.isNull.sum to count all the columns that have null values. So if you put this, you'll see that the age column has the smallest one. So you might need to use some data processing techniques to fill up the age one. There's also a way you can visualize. So with this one, it can give you, when you put this seaborn here and then this matplotlib, you can plot. So the seaborn will give you a bar plot, and you can plot the class of the person and whether they survived or not. And this will give you the percentage of someone in a particular class, the percentage of them surviving or not surviving. So we also have more machine learning techniques with scikit-learn. So here we have, remember, you can import. So from this sklearn or model selection, remember, you can import something like train test splits. And if you remember, train test splits is when you have your data, you remember you don't use everything to train. You're going to leave some to test. So you can use 70% to train, 30% to test to see how it's doing. But in this particular code, for this particular outcome, you're going to replace it with what you're trying to classify. So what is the column name of that particular one? So in our Titanic data set, it is survived. We want to know if the person survived or not survived. So it means this outcome here will change to survived. So we'll go through that particular one now in this code. So we have the Titanic tutorial. If you remember, you import pandas as PD just for data manipulation and analytics. You can also, from sklearn or model selection, you can import train test splits. It's easy for you to be able to split your data in a percentage you want. Standard scalar. So if you remember from another class, you might want to put your values on a similar scale. So remember the number of bedrooms example versus the size of a house. If the size is ranging from 0 to 2,000 square feet and the number of bedrooms is 1 to 5, you want to make sure both of them are on a similar scale so the size does not dominate the number of bedrooms. We also have logistic regression. If you remember from the first class, we have different algorithms for machine learning. So logistic regression can help you classify different outcomes. So for example, you can have spam or not spam. In our case, in this tutorial, we have survived or not survived. There's also accuracy score to help you know how your model is doing. So how well did it perform? So if you got 90% of the data correctly, that means the accuracy will be 90%. So these are just how you can import all of this. So this sklearn data set has all of this. So instead of long codes, you can easily call all of this to help you with that. So the next thing you do is to load your data set using this URL here. So from the last class, we're able to use this. So I'll just copy this. So these are all the imports here. Okay, there's a problem with the network. But anyway, this is just to import all of the things you need, all of the files you need. For the next part, remember the data processing part. So if you look at the columns of the Titanic data set, you have some things like number of siblings, you have where the passenger embarked from. So you have a column like SIB, SB, you have a column for parents, number of parents, that's like PARCH or something. You have embarked, where they embarked from, what city they embarked from, and so on. So you might only want the relevant columns that can help you state whether they survived or not survived. So in the Titanic data set, you have names as well. But someone's name does not determine whether or not they'll survive, right? So you don't need that column. So what you might need is the class, the sex, the age, the fair, and survived and not survived. So some of these things here might help you determine whether or not they survived. So you just take the relevant columns you need. So remember, if you use df.head, it will give you all the column headings, right? So there are plenty more if you look at the tutorial. So we need these ones because it will help us. It has good features that can help us determine whether somebody will survive or not survive. So remember the age column. So you can handle missing values. So if you look at the data set, if you open that CSV file, you see that the age column has some missing values. And you can try and fill in those missing values by using the median of each of the age. So to do that, you simply write this code here, df.age.fillName, and so on. So this will, in any empty field, it is going to give you the median age and just replace that. You can also convert to categorical features, your categorical features to numerical. So remember from the data processing class, the computers will handle processing of numbers easily, right? So instead of using male and female, you can use zeros and ones to help you compute it better. So now, for this particular one, this X value, so remember you have your input and the output, right? So when you are trying to predict the size of a house, you use different features. You use number of bedrooms, the size of a house, the number of floors, and so on. And you wanted to predict the price of a house. So in our case as well, we can use the class, the gender, the age, the fair as the input to help us classify whether this particular individual will survive or not survive. So it means the input now is going to be class, gender, age, fair. And remember, it's commonly denoted as X. So that's why here we have all of these columns. So remember here, df is equals to this now. But we want df to drop the survived columns because that is what we want to try and classify. So it's going to remove that survived columns, but put all of this here in the X file. And then we have the Y. So the output is commonly denoted as Y. And so that is what we're trying to classify. So here we have df survived here. That's right. So remember, when you have your data set, you need to split it, right? because you want to see how well it's doing. So you want to make sure it's performing well on data it has not yet seen. So it will use 70, so it depends on the test split you use, the train test split you use. Remember, you can have 70-30, 80-20, 90-10, and so on. So this particular code here, train test splits, remember, instead of writing a long code, you can simply use this line here to split your data sets. And what you will need to put is the input, which is this 4 here, and then this Y here is the output survived. Then we have the test size 0.2. So 0.2 is 20%. So now you want the test size to be 20%, which means the training will be 80%. So now if you pass this particular data set, it's going to use 80% to train and 20% to test. And then this random state equals 42. Just makes sure anytime it's generating random values, it is the same random values for easy evaluation. So here we have, and then when you put this train test split, it's going to give you 4 different variables. So previously, you know something like this, only one word at the left-hand side, right? But now you have 4. So it simply means that because this has 4 outputs, it's going to put the first one, x train equals to the first one, the next one, x test equals to the next one, y train equals to the next one, y test equals to the next one. So also, remember why you should already know why you need the train and the test, right? But remember you have your inputs here, right? And all those inputs should have the answers, the outputs. And the same thing should also happen for, you have your inputs, and all those ones have the output, that's Y train. But remember, you're splitting it, so you also have your test sets. And the input of those test sets should also have the outputs. So remember the test one, this one is the one you use to evaluate to see how well your system is doing. While this one, X train and Y train, is the one you're going to use to teach it. So it's like, when you're in class and when the teacher is explaining something to you, they're giving you the example and the answers to it, right? Then later on, they can then test you with it, and they wouldn't give you the answers. Okay. So we have model evaluation. Why evaluate a model? So after training a model, you need to know how well it predicts new data. So we have basic metrics for classifying data, spam or not spam. So accuracy is basically how many predictions were correct. And for predicting continuous values, like house prices, you use something like mean squared error. So it tells you how far off your predictions are on average. So you want the error anytime you're trying to predict continuous values, you want the error to be close to 0, right? Because you don't want it to have any error. So there's also a tutorial I'll share with you on accuracy. So this image here at the right is a confusion matrix. So it's this TP stands for true positive, FP false positive, FN false negatives, and TN true negatives. So it all depends on what you're trying to classify. So let's say you're trying to classify whether a particular fruit is an apple or orange. You choose which particular class you want which particular fruit you want as your positive class or negative class. So it depends on you, not that one is positive or negative. Just depends on you. So let's say you're using apple as the positive one and orange as the negative class. The true positive is the one, when you're testing your system, is the one, the number let's say apple is a positive class, right? So it's the number the system, how many apples did the system correctly get as positive? So that is the true positive. So it's trying to you have false positive as well. So if the system says something is an orange, meanwhile it's supposed to be an apple, that can be false. We also have true negative. So if you're using orange as a negative class, and the system says this is an orange, and it is actually an orange, that's true negative. So we also have false negative. So if what you're trying to predict is an orange, and the system says it's an apple, that's false negative. So it depends on what you're trying to predict. But you should, if you have 2 classes, it's going to be 2 by 2 this way. So we also have sklearn linear model import logistic regression. So if you're trying to classify something, remember you can use logistic regression, right? Spam or not spam, in our case, survived or not survived. So this is how you can do it. First, you need to import logistic regression, and then you have model equals to logistic regression here. So just telling it that you're just putting logistic regression in a variable model. I remember model.fit. So if you remember from the second class, .fit is used to train. So basically, you're trying to fit your X train to your Y train. That's this one here. So it's just going to give it all the X values. So for each of them, it will show the system this particular row, and it's going to show the answer, whether they survived or not survived, right? For our Titanic data set. And then this predict X test. Remember the part you left out, the 20% of data you're using for test. You can try and predict what those X tests will give you. And when you now do that, you can use your accuracy score to now compare the tests, right, and the predictions. So remember, this one is all your data of your test in your test set, the input, right? And then you all have the answers. So you want to check, it's like when someone is marking your work. Remember, when you write an exam, you only know of the X, right? The inputs. So the particular thing you're trying to solve, but it's not going to give you the answers. The person will not, the lecturer will not give you the answers. So when the lecturer is marking, they are going to take the answers, right, and compare it to your work and see how many you got correctly. So it's just taking the answers now and the predictions, your answers, your own answers, and it's going to try and predict it and compare it to see how many you got correctly. So if the system says got 90% correctly, the accuracy score will be 90%. So that is accuracy. We also have other algorithms. So we have random forest classifier, SVM. So you can check your notes for that one. But random forest, so it uses different decision trees. So we treated decision trees in week 2. So random forest is going to just basically calculate all the correct votes, and then it's going to use that as the answer. So let's say you ask friends, for example, is this an apple or an orange? You're asking different friends of their opinion on whether they will say this is an apple, this is an orange. So at the end of the day, you're going to take the most answer, and that's what's going to be your own answer. And the SVM is just the margin. So it is how well it separates 2 different fields or different classes. So let's say, for example, with football, if you want to separate the people wearing blue jerseys from the players wearing red jerseys, you will put a line, and then the line that can separate them the most is what SVM is all about. You're trying to create the margin that can separate those 2 players the most. So, and then this is how you can get accuracy. So if you run this code, so you can try different algorithms to see which one gets you the best accuracy score, or there are other metrics as well from week 1. And I'll also share a lecture notes. So we have logistic regression, random forest classifier, and so on. But if you run this code, the one with the highest is going to be random forest. I think the logistic regression will come in next and SVM next. There are different things you can also change with this. So for random forest, you can look at something called n_estimators. You'll see it in one of the tutorials I'll send, and it will help you improve your score. So it can help with overfitting. We'll come to overfitting soon. So there are more data processing techniques you can also have. For example, remember with feature engineering, you can create like a new column, right? So let's say you have the age column, and you want to create another column for each child, like this. You can say, remember, if from your programming knowledge, so all of the age that are less than 18, you can put that in the column each child. So let's say they are not less than 18 and it's false, it will put 0 in that particular row. If they are 18 or older, it's going to put the value of 1. So this as type int, it simply changes the true and false to 1 and 0. So that's just what this as type int is for. You can also fill missing values with this age. So you already have this as well, this age here. You can also fill with back. You can use the mode. You can also use someone's title. So remember, maybe it depends if doctor or professor has a chance of, if professor has a chance of surviving more than doctors, that can be a feature in trying to determine whether someone will survive or not survive. So if you want, you can add the title here and then remove all these keys, maybe the full stop and so on, that can affect that. So that is the extract here. So you can also, this is also another way of, remember when you are trying to change gender, female and male, to 1 and 0. This is another way. This .get dummies can also change that as well. You can also drop the columns. So remember our own, we just use, if you go back to the previous slide, we just use df and this. But instead, you can also just drop all of those things you wanted and then left that df. And then this family size is also another way of adding another feature. So you have, in your Titanic data set, you have a column for siblings and you have one for parents. You can create another column called family size by just adding siblings and parents together. We also have overfitting and underfitting that we discussed in lecture 1. So overfitting, imagine memorizing answers for a test without understanding the concepts. So you might fail on different questions. So overfitting is similar. The model performs well on training data, but poorly on unseen data. So there's a way you can check the accuracy of your training and accuracy of tests. So if you see that it is doing well when you're teaching, like for example, teaching the students, they are doing very well. But when it comes to exam, they are not able to do well. So it means it's overfitting. It's generalizing only to the examples. The students are only learning the examples you gave in class, but cannot provide the answer on new concepts. So that is overfitting. So, and it's the same way for the model. So it is understanding when you're training it, but when it comes to testing, it is not working. So with underfitting, is like not studying enough. Underfitting means the model is too simple to learn the underlying pattern of the data. So here on this particular one, it is not doing well. It's unable to learn on the training data set, and is also not able to learn on the, give correct answers on the test data sets. So that is overfitting. We also have something like regularization. So it is a way to prevent your model from like studying too hard and just memorizing data. So it gently nudges the model to be more general. So it helps with overfitting. So anytime you have overfitting problem, you can use regularization to try and fix this. There are different regularization techniques that you'll see in the notes. So any questions from this so far? Okay, so we'll go to the recap of fundamentals. The code. Yeah, so the tutorial. Yeah, so the tutorial will take you through it. So I've taught you the basic concept from last week. So the tutorial I put, you should use that concept from last week to be able to run what we've done in this particular class. So we'll just go through like a recap of fundamentals of machine learning from what we've done in this particular module. So we have machine learning. So machine learning is a subset of AI that involves training algorithms to predict outcomes and identify patterns and make decisions based on data. So you're going to give it what the input and the output, and it should learn the rules to be able to take you from that input to the output. So with supervised learning, it uses input-output pairs to learn a function that can predict new outcome. So remember, we went through classification for predicting categorical values, for example, spam or not spam. We went through regression for predicting continuous values, for example, price of a house. Then remember, we also have training and testing data, so you need to split your data into training and test sets. for training to learn and testing to evaluate the model performance. We also went through unsupervised learning to infer patterns from unlabeled data without reference to known or labeled outcome. So clustering is basically grouping a set of objects in such a way that objects in the same groups are more similar to each other than to those in other groups. And also association. You can discover rules that describe portions of your data, such as people that buy X also tend to buy Y. I'll take you through the notes from the previous class. So if you run all of this code, so the explanations are also there. You can try and use k-means clustering to try and group different data, similar data, close in different groups. So remember, you have your imports. You can make different blobs as well. So let's say you have something like this in your data set. From looking at this, you can see it has 3 different clusters, right? So you can pass this to a model, a k-means model, to help you actually separate them. So sometimes the data might not be as spread as this. Sometimes it may be very close to each other. But with k-means, it will put similar data to each other. So like this particular data, it might put it in cluster 1, this one might be in cluster 2, and this one might be in cluster 3. So that is k-means. We also have model evaluation. So for classification, we have accuracy, precision, recall, and F1 score. So we've gone through accuracy in this class, but there's also a tutorial for accuracy again, precision, recall, and F1 score. For regression, there's also MSE, RMSE, mean absolute error. There's a tutorial for that as well. We have different validation techniques, train, test, splits. Cross-validation is using parts of the data to train and validate the model to ensure reliability. So basically, you want to test on different parts in your data set. You want to make sure you've tested on different particular parts of your data set. So overfitting and underfitting. So when a model learns the training data too well, so including the noise which hampers its performance on new data. So it occurs when a model is too simple to capture the underlying data patterns, resulting in poor performance on both training and new data. So there are different techniques you can also use to fix overfitting and underfitting. So we have L1, lasso, and L2, ridge as well. So with the ridge, it's basically making sure that you remember, like for example, in predicting price of a house, you have different features, number of bedrooms, size of a house, and so on. You want to make sure that all of the features are making an impact in predicting that particular outcome. We also have lasso. So lasso is basically trying to remove all of the data that are not needed. So all of the features that might not necessarily be needed. So like, for example, if you're baking something, you might remove the ingredients that don't have much impact. So those are, there's something like ridge regression and lasso regression. When it comes to regularization, it's just going to put a penalty on the coefficient. So if you're looking into the math about it, it just puts in a penalty on those particular features. So best practices in machine learning, we have data quality. So high quality data is critical for building robust models. There's no one-size-fits-all algorithm, and testing different algorithms based on the problem context is essential. So I've put the code of 3 different algorithms. You should have a total of 5 from all the nodes. There should be one on logistic regression, SVM, random forest, decision trees, k-means, linear regression. There should be at least 6. So I'll just go through questions and answers now, and then I'll hand over to the person in charge of the next lecture. Okay. So any questions from class first?
Actually, you have done so well, but the issue is practical. You know, sometimes you go a little bit, maybe in a such way that you are not as if you are dealing with people that already have the prior knowledge about the programming.
Oh, okay.
When you are doing coding, after you have in the patterns of coding, the other text pattern, you just touch it a little bit.
Oh, okay.
You know, after the coding of the variables, the text pattern of the coding, maybe you want to maybe classify the name of the particular programming you are coding. You do not explain that part a little bit.
Oh,
Also,
okay.
The other part of maybe different, the other part of the library like matplotlib and TPU.
Oh, okay.
What is the difference between the two?
Oh, okay. So the matplotlib is just a library to be able to help you plot your any visualization you might want to have, and then there's Cbon as well for plotting different bar charts if you want that. But the thing about the fundamentals of machine learning, so prerequisites for ML practicals is programming knowledge. So that's why I put the Python tutorial there, because how we're supposed to start from is after the Python knowledge, then you move on to machine learning. So it's usually a prerequisite in all machine learning practicals to have Python knowledge. So before you start like with machine learning practicals to have done something in programming. But with that Python simple Python programming, all you need is this particular part here. So in anywhere you don't necessarily understand, let me go back to the notes. For example, okay, so let's say this one here. So remember how you have import pandas as PD, right? So that part has been explained to you. So anytime you see pandas, so let's say you forget what pandas mean, you can simply go back to the notes. So for example, this one has data manipulation analytics. But if there's something I missed, because it's very popular, it's very common, there are different libraries, so you can check the scikit-learn library and just see what they mean. So in any part that I might have missed in the explanation. So for example, this the read CSV, because it's quite common, you can easily get the explanation online. So you can check different libraries, but this particular one is just to read an email, so to read this particular CSV file. So I know this was a question in the last class. With the .head, so it's simply the comments are here. So remember, this hash is a comment, it's not going to run. So the explanation is there. So displays the first 5 rows of the data set. So I remember this data is a variable, right? From the last class, we had this as a variable, data equals to pd.read CSV. So this data here, anytime you write .head at the end, it's going to display the first 5 rows. And remember this print is also because we have this print here, which helps you display file. So what I'll suggest is, since some might not have the programming knowledge, so it is best to go through Python tutorials first. So there are different free Python tutorials, and then you can use this particular slide if you need more. But I've put the basic things that you might need at the top of this slide for now. And then this dot is null, so it's just simply standard as well to count all the null values. So null just basically means empty, missing values. So it's just checking data dot is null, will check, is this data null, is this data missing? And then this dot sum is just going to count the number, sum all of the values that are missing. So that's just what it means. So you can simply use this whole line here to count the missing values per column. That's what I mean. And then remember, the same way you're importing NumPy and pandas, right? You can also have different imports from the last class. So for example, Cbon, matplotlib.pyplot. So this one here can help you plot something just for visualization. This Cbon here can help you use a bar plot. So that's what it means. And also, each of these have documentation. So you can open the documentation as well. So In this case, you can see, okay, what does this seaborn do? So if you simply put it like in any Google search or something, it's, if you open this, you'll see that seaborn has something called bar plot here that you can use to display bar charts. So this x equals to p class. You want on your x, remember you have your x and y axis. So on the x axis, you want it to have p class. On the y axis, you want it to have survived. And then this data equals to data. You're just simply putting the data you had previously in this. So some things have you can pass in 3 different values and separate them by commas. But this is the standard for it. So this bar plot has 3 values. Remember, when you separate something by commas, it's different values. So this first, anytime you have bar plots, you should have like 3 different values. So one should be the x, one should be the y, and the third one should be the data. Then this dot title is just basically showing you the title of that particular plot. This dot show is just to show you the plot. So all of these things, they're available online as well for you to see. Yeah, it's going to show you the plot. So once you run it. And then for this particular part, you use the Titanic tutorial data sets, tutorial that I'll send in this particular lecture here. There's also another tutorial anyway that I also sent. So they all have the same way this particular lecture notes here, this particular tutorial notes had different comments explaining the code. Those tutorials will also have that. So, okay, so now I'll just go through the questions in the class. So you can try different models to see which one will help you the most. So like in our tutorial, the random forest classifier gave us better results than the logistic regression one. Wasn't giving you the accurate results. So if you try different data processing techniques as well, so if you use the one in this current note, your accuracy would improve. Okay, for the syntax and step, it's best you learn it. So just use the tutorial as a guide to help you understand how machine learning should be done. So the Excel file is on the classroom. So if you open that particular tutorial, I've also put it on the Telegram group. If you open that tutorial, you should see that link. Okay, so I think that's all for today. Any more questions from the class? Oh, okay. So maybe when you're going through the tutorial, yeah. Mm.
Just like after you teach it, like when you're talking about the data entry, and you brought out overfitting and underfitting, you understand? Like it made me some people confused about it. How will the data be considered trained? Like just as
Oh, okay. So when you have your data set, you know you want it to learn, right? So remember that train test split. You want to use some percentage for training and some for testing. So there are different train test splits. So let's say you're using 80% to train, 20% to test. On the 80% that you're using to train is what you're actually going to be showing, let's say the computer, for example. You're showing it this particular input and this particular output, right? So it's going to learn, okay, when this is the input, this should be the output. So just like in class, when you're learning from the teacher, they are showing you the example and this should be the output, right? Then with the test, you're going to give it the inputs. So you're going to show it the inputs, like let's say questions, for example, but you're not going to show it the answers. So based on those questions and the answers you give, it's going to, sorry, the answers the model gave, it's going to compare how many it got correctly. So let's say you've written an exam, for example. Remember, you're going to give the answers, right? It's going to give you the questions, like inputs, and you're going to give it the answers. So it's going to check if those your answers, are they the actual correct answers that you're supposed to have? So those answers you give are like the predictions, right? What the model is predicting. And then the answers, the correct answers will then be compared with the model's prediction to see how well it is actually doing. So that's the train test split. Okay. So any more question? Any more question? Okay.
And you are doing your accuracy question, and you have 80% correct of data. That's accurate, right?
Yes.
Then the remaining one is what?
So it's classified them falsely. So that means when you say 80% accuracy, it means it just got 80% right. So it was able to predict 80% of your data set as correct. So your predictions are just 80% correct. Okay.
You have accurate or accuracy. That is the correct. The one that we are testing correct and give you the correct answer. And the one that you are not testing is called what?
Sorry, you're testing when you're trying to get your accuracy.
And give your machine 80% and give you correct answer. That one we call it accurate, right?
Yes.
Then the remaining one is what? 20%.
The remaining 20% you got correct. It's still from the test data set. So it's just saying among your test data sets, if let's say you put in 100 inputs or 100 images, and from that 100 images, it was able to say 80. When you compared, you saw that it got 80 correct. That is what accuracy is about. Yes, so that is what it is. Okay. So so I'll hand over the model now. So the data learning basics to Dr. Charles, if there's no more question. Okay, so he'll introduce himself when he comes up a bit. Okay, so thank you.
Okay, all right. I think I was unmuted. All right, those online, can you hear me? All right. Okay, all right. So I'd like to see the questions on the that's the online platform. Okay. Those who are asking that they put in for physical class and they are waiting to get mail before they come for the physical class. Yeah, those who who asked questions on the online platform that they put in for physical class and they're waiting to get mail before they come for physical class. If you put in for physical class, you don't need to wait for an email. You can come for your physical class. There was a time we sent mass email to those who put in for physical class, and we saw large numbers of people. But surprisingly, we are seeing few people now. I don't know if you are still expecting mails again before you are for physical class. So if you know you're putting for physical class, you don't need to wait for an email before you come for your physical class. So please, once you put in for physical class and you are sure you put in for physical class, you can come in. In fact, we'll be able to admit you immediately once you know that you are for physical class. So you don't need to wait. Come in for your physical class. And we actually sent out a form last week for those who are interested to join in as a physical class student. If you know you register for that form and you're interested to join the physical class student, you can also come for your physical class. You can also join the physical class students too. You don't also need to expect an email. If you register if it's on that form, please, you can also come in for physical class. So later on, we can send an email to, regularize that. But if you know you're interested to join in as a physical class student, you are in Abuja and you can attend, you can get that 70% attendance as a physical class student. You are free to come. So also those who are expecting an AI dashboard separately from your you only have one dashboard. Kindly know that you only have one dashboard, and that's your login details that was created to your dashboard where you actually learn your that is your GST courses. So that same dashboard is what we are still using. Very soon, all your facilitators will be able to communicate with you on that same dashboard where you will have your own costs on the dashboard. So I think the IT team are working on that to set up a more like a course on that dashboard where you can your own course on that dashboard where you can communicate with your facilitator. So at the meantime, you have the Telegram group. The Telegram group is there where you can also see information on the that will be posted by the facilitators on your own various Telegram groups. So very soon, I think time to time, we are looking towards maybe a particular day of the week where I think I will speak to the facilitator where they will be free to communicate with you guys, where the Telegram group will also be open so that you guys can ask questions on the Telegram group and also have a better communication, because I believe that interaction on daily basis is also will help to familiarize with what the facilitator has been teaching during the lecture. So I think Dr. Charles is here. So I'll invite Dr. Charles for the setup and all that. So I think it's the deep learning. All right, for the deep learning course.
You want to use the place? I have to use my hand. Okay.
Okay. Can you hear me? All right. So, good morning. I guess you're all masters of machine learning at this point. Because I see that we've gone through a course on introduction to machine learning. So before we start, can we get to know each other? My name is Charles. Okay, I work in this university. I'm in the Department of Computer Science. So can we all have a short introduction? Let's start from that. Okay. All right. What do you do, or what's your background? What do you do? What's your background? Yeah, educational background. What do you study? Or what do you study? Yes. Okay. All right. Who are you? Okay. Hey, you can sit down. Yeah. Okay. Okay. So this is important so that we know how to address ourselves. Okay. What about you at the back? Okay. That's all good. What about you? What about you? Yes. Okay. So we have diversity. What about you, sir? Huh? Not yet in school, so but this is my first time. Okay. Cool. Sir, what about your class? Okay. Oh, okay. Cool. You? Accounting. Okay. You are still applying to university? Okay. Cool. Madam, what about you? Awesome. Sir, what about you? Okay, sir. My name is okay. How about you? Okay. How about you? Okay. All right. Should I ask you too? All right. So it's nice to meet you all. So obviously we have people from diverse fields, from social sciences to engineering to pure science. The course is about deep learning. So, oh, okay. So the course is about deep learning. I have not. Oh, present. This one. And then share my screen.
Yeah, share screen. So you can share your entire screen if you want, let the window up, or you can share the entire screen.
Okay. Let's just share the audio, I guess.
Yes. Maybe click on the, okay.
All right. So, like I said, obviously we are all from diverse fields, pure sciences, engineering, and social sciences. Hopefully, we should be able to get. Hopefully, we should at the end of the course we should be able to get basic understanding, and also the goal would be that in your various fields you can apply these techniques to solving problems within your own domain, which you are most comfortable with. Throughout the course, we're going to try to be as hands-on as possible, but there's a lot of theory behind it. So maybe we will still touch a little bit on the theory. So in terms of the hands-on material, we are going to be writing Python codes. I see that some of you already started doing something in that direction. So we're going to be writing codes in Python, and we're going to be doing a lot of calculation, very, very basic calculation, addition and subtraction of matrices and multiplication, okay? Because that's basically what deep learning is, all right? So for those of you who maybe sort of have a slight phobia of mathematics, we are not going to do crazy mathematics. We're going to just do the basic ones you need for you to understand the course material. All right, so having said that, I think we can start. The course is on, the first series of the course is on the basics of deep learning, okay? The goal is we want to understand what exactly is deep learning, okay? I'm sure a lot of you have heard about it, all right? It's a buzzword now, machine learning, deep learning, and all that. What exactly it is, it's not really as complex as you think. It's something you probably already know, but we're just going to put flesh to it, okay? So the learning outcome for today would be to get a little bit of understanding, okay, of where we are now, okay, and where we were before, okay. That's to say, we are going to look at some little bit of history on the artificial neural network, what it is. We are also going to look at, I'm sure you've seen this before, differentiating between traditional programming and machine learning. And we are also going to differentiate between deep learning and traditional machine learning models, okay? Like the ones you've been through, the random forest, the linear regression, and the rest, okay? We are also going to understand what we mean by GPUs, okay? Because we need them when we are running or training these models. We're also going to try to understand what TPUs are, what tensors are. For those of you who have done a little bit of mathematics and physics, you probably must have heard the word tensors or arrays, okay? We'll try to understand how to manipulate these tensors in Python and also understand the basic training workflow for any deep learning project, okay? All right, which is not really very far from what you have seen in your machine learning class. But this time we are using a specific class of model called deep learning models, okay? So that's basically it. As we continue, if you have any question or maybe you're confused at any point, just stop me so that I can re-explain, okay? Sometimes for some of you some of you just seeing this for the first time, it may look really complex, but it's not, okay? Which is why you need to stop me and say, okay, please explain this, let me have a better understanding, okay? So your attention is very, very important, because if you don't pay attention, you won't understand where you're getting it, where you don't understand. Okay, let's try to make this as interactive as possible. Everybody here must have heard of the word artificial intelligence. It's in the news, okay? People talk about AI, you know, it's, in fact, if you want to sound really geeky, if you want to sound really smart, just put AI in your presentation. People will see you as, this guy is really cool. So what do you understand by the word AI or artificial intelligence? Any questions? Let's try and see if we can discuss. You've taken, we all have been going through a course on machine learning. I'm sure you've heard that word before. So who can tell me? Any suggestions? You want to say something? Yeah, sit down. Don't worry, sit down. Yeah.
I always understand about this to understand that shares is like a web frame whereby we design by doing web page, different design, giving a machine an instruction to do, whereby human people can't do, like running a scale of what we do about imputing and computing. Those of that human itself will not gain or cannot carry that capacity. The meeting as artificial intelligence can make that run that smoothly, and it has the option of that it's fast and it's easy for us to ground.
Okay, that's a good one. Any other addition to that? Sorry, you want to say something? Let me call names now, since everybody's keeping quiet.
From my own understanding,
Yeah.
artificial intelligence is all about it's all about the aspect of machine that can run the program without the help of human
Intervention.
human interpretation, human being.
Okay.
It can run a program within a short time without
Okay.
the help of any human being. That's the nutshell.
All right. What about you? You're going to say, yeah.
Yes.
AI is like, it's making a machine think like a human. So that is, as a simplest.
Fantastic. What about you?
Transform the human intelligence to a machine to do what human can do or better than human.
Good. Everybody has said, of course, something really cool. You're all correct. Okay. We just need to give it some more flesh. The goal of AI, at least the initial goal of AI, okay, is to replicate human intelligence in machine. Simple. Okay? All right? We are smart as human beings. Okay? But we might be limited, okay, by strength. Okay? We might be also limited by, majorly by strength. Okay? So what if you can build a machine, okay, that can think and function like a human being? All right, that's the goal of AI. Okay? So by that, we cover all the things that humans do that we want to try to replicate. Okay? Like, for example, we can say humans are able to recognize people. Okay? If I see you, if you tell me your name, it's imprinted in my brain. Okay? And when next I see you, I would say, okay, this is Abdul. This is Michael. Okay? That is what we do naturally as humans. All right? But how do you make a machine, an electronic device, behave like that? Okay? So the process of now taking a machine that is made by man to make it function and behave like humans to solve different tasks, okay, is artificial intelligence. All right? So you're creating intelligence, but artificial for machines. That's the idea. Okay? So there could be all the tasks that you can think of as humans, and even more. Okay? We want to be able to see how we can replicate that functionality within humans. And some of you might say, okay, maybe are we there yet? Well, we are not. We are still very, very far from it. Okay? Where we are right now, we are actually very good at replicating specific tasks that humans do. Okay? For example, the task of seeing people and recognizing people, we can do that with machines. Okay? All right? The task of driving a car, okay? That can also be done now with self-driving cars. All right? Those are task-specific functions that we have been able to achieve. Okay, but you agree with me that as humans, we can put all these things together and function. Okay? We can recognize you, we can drive, we can do so many things. In fact, you can even do things that you never thought you could do. Okay? We're not there yet. All right? What we can do is these task-specific operations, and that's sort of the limitations that we try to, the gap we try to bridge in research right now. Okay? But basically, that's just a bit, that's digressing a bit. Artificial intelligence is basically replicating human intelligence in machines. Simple. Okay? Whatever it is that defines intelligence for the humans, we want to try to see if we can put that same thing on a machine. Okay? All right, so it's the ability of the computer to perform tasks commonly associated with intelligent beings. That's artificial intelligence. Okay? So you agree with me that it's actually a broad field. Okay? It's a lot broader than people think. Oh, person. Okay, so what is it? Okay, so having said that, all right, remember I said artificial intelligence is very, very broad. Okay, we just talked about how we are going to replicate human intelligence. Yes, that's artificial intelligence, isn't it? But how are you going to do it? Okay, it sounds really cool. Okay, I want to do AI, and it's easier to say things than have them done. Okay, but how do you actually do it? Okay, how do you actually pick an electronic system? Okay, and make it in such a way that it thinks and functions like a human being. Okay, all right. There are many ways that computer scientists have tackled this problem before. Okay, one way is just to write programs. Okay, smart people will come up with algorithms. All right, just code it. All right, if then statement and all this stuff. Okay, now it turns out that there's a limit to what you can do with that kind of technique. Okay, there's a limit. Another way people are beginning to look at tackling that problem of intelligence is through machine learning. Okay, so within the AI spectrum, okay, there are different tools for achieving, replicating intelligence. Okay, one of them is actually called classical AI. Okay, where you basically look at the problem and you try to maybe write programs, try to do some rules, if then statement to try to solve the problem. Okay. Another area is why not allow the machine itself to learn? Okay. If you think about a child, when you give birth to a child, okay, do you tell the child do you teach the child how to recognize people? No. Okay. Do you even teach the child how to identify, interact with the world? You don't. Okay. The child grows up. Okay. Knows that this person is seen or he is seen all the time is the mother. Okay. So it learns from information around its environment. Okay. All right. If you say to a child, there is electricity in that socket, don't touch it. Yeah, you've taught the child, yes. But most times the child will go probably touch it, and then if it shocks it, it knows not to go there again. It learns by itself. Okay? All right? When a child stands up, okay, and is trying to get up this pavement, if he falls the very first time, he knows that that technique is bad. It causes it pain. He won't do it again. All right? So you expect the child to interact with the environment and learn, okay, as it grows. In the same way, in the field of machine learning, we just allow the machine to learn from data. Okay? So we give the machine data and we expect that the machine will learn different patterns. Okay? You don't tell it what to do, you just give it the data. All right? And that machine is able to figure out, the patterns within the data. And that way, we can achieve the intelligence that we seek. Okay? So that's machine learning. And that's what you've been doing in the last few weeks. Essentially, the study of algorithms that learn from examples and experience. Okay? Instead of hard-coded rules. Okay? And they make predictions on new data. Okay? So what you see here is a caricature example of the difference between the two. Okay? One being classical AI, the other being machine learning. Okay? Suppose you want to maybe make some really nice fried chicken. Okay? Women will understand me better in this case. All right? Now, you get your ingredients, which are the inputs. Okay? And then the woman would say, okay, these are the rules. Okay? To follow, the steps to follow, like the menu, the recipe, before you can get the job done. Okay? You cut the vegetables, you season it, like you're writing a program, step by step. Okay? This is how you would do classical AI. All right? At the end, the goal is to output a meal. Okay? For machine learning, it's the reverse. Okay? You have the input. Okay? In fact, this is actually called supervised learning. You have the input, you show the machine the output, okay? And let the machine deduce the rules. Okay? Is this clear? Why do you need to do this? Because you may not be able to capture all the possible combination of rules in the world. Okay? Different people may be able to will come up with different recipe or whatever it is for this output. So you want to give the machine as many data points or many data as possible so that they can learn those rules. Okay? So this way it's a lot easier to create an intelligent machine. Okay? Than what you have here. So that's the machine learning. And like I said, that's what you've been doing in the last few weeks by training random forest classifier, maybe naive Bayes, linear regression, and all that. Generally, that's machine learning. What is deep learning? All right. At this point, let me ask the question. I'm sure some of you have heard about what deep learning is. So what is deep learning? You're laughing. You want to say something? Mm-hmm. Machine learning is artificial intelligence. Okay, yeah.
Let's say you have a basic,
Mm-hmm.
and you want to add more.
You want to add more?
Yes, about basic learning.
Okay. Okay. I get where you're coming from. So you're saying, okay, say you have basic learning and you want to go deeper, then you do deep learning. Actually, that's not true. That's not really necessarily true. That is not the right way to put it. Yeah, you want to say something?
That is more of interpretation of data.
Not necessarily, no. Who else? Okay. So it's good. At least we all have a clean slate. We can all learn at the same time. So what is deep learning? Well, deep learning is also a typical technique in machine learning, okay? But that came from something called artificial neural networks, which we are going to see in a moment, okay? So we'll say that deep learning is a subfield of machine learning, okay? All right? It's a subfield, so we are going, okay, deeper, as he said, okay? It's a subfield of machine learning, all right? With a focus on learning representations, all right? The words may be big for now. Don't worry, we'll break them down. So we are learning data representations as successive layers of increasingly meaningful representation. Big English, okay? Let's pause for now, all right? Let's look at how we even came about deep learning. Maybe you understand the basic idea, okay? In general, this is the graph, okay? Have this at the back of your mind. Artificial intelligence encompasses everything, okay? Our goal is how do we replicate human intelligence in machines? That's our goal, okay? There are very many ways to do this. One way is to let the machine learn by itself. That's machine learning, okay? Now, within the space of machine learning, okay, there are different models, all right? You have seen them already, okay? Naive Bayes, all the things that you've learned, okay? Those are different models. But one of them that has been of interest lately is the artificial neural network, okay? Which we are going to talk about in a moment, all right? Now, within the artificial neural network spectrum, you now have deep learning, okay? So this should give you a picture of where we are headed, okay? We'll look at what artificial neural networks are, okay? And then that should give you an idea of what deep learning is. And hopefully, once we get this, we can close for today. Okay? All right, so how do we arrive at deep learning? Okay, how do we arrive at this very esoteric definition? That's what we want to talk about. Okay? Now, if you recall, our goal in artificial intelligence is to say, okay, how do we make a machine as smart as humans. That's the goal. Okay? And what is that thing that makes you smart as a human being? That processes information? Your brain. Okay? So, many, many years ago, some scientists thought, okay, if we are able to replicate how the brain works, okay, then in machine, then maybe we will be able to get machines to think like humans. And you understand the line of thought now, okay? Because the brain is the central processing point of the human being. So let's replicate the brain in machine. And if we can do that, maybe we can get machines to be smart, okay? Now, before that time, nobody knew what constitutes the brain, okay? We just know that we have, we are talking about, I think early 18th century, right? 19th century, early 19th century, okay? Nobody knew what happened in the brain. In fact, that was almost at the start of revolution in science. Okay, nobody could see what you couldn't understand until this guy, Ramon Cajal. Okay, he's not a computer scientist. Okay, but his work has been has revolutionized. In fact, his work started the birth of this thought process. Okay, towards that time, humans were able to invent a microscope. Okay, and if you recall, so in your science class, there was this famous scientist that drew the image of I think a cockroach or so, and enlarged it, and people could see what cockroaches are made of and stuff like that. Okay, now this guy, what he did was to say, okay, what constitutes the brain? Okay, so he was able to take part of the brain cells, put them under the microscope, okay, and drew what constitutes the brain cells. Okay, so he came up with this diagram, and he realized that the human brain, these brain cells, they are very, very different from the normal cells that we have. Okay, they have connections. All right, one connects to another. They are interconnected. Okay, so he came up with this. He postulated that perhaps the way we learn is, as a result of these connections in the brain. Okay, that was his contribution. All right, and he published the work sometime in 1906, and of course everything died, and there were no computers at that time. Okay, but this diagram gave scientists, mathematicians, and the like sort of like an idea. Okay, perhaps maybe we can mathematically represent these connections. Okay, all right, and use it to learn a particular we can use to learn a pattern. Okay? All right? Those guys is Mikolov and Pitts. All right? They came up with this. All right? And of course, there were no computers at that time. We're talking about 1943 here. There were no computers. Okay? So how do we achieve this goal of intelligence? This guy, Rosenblatt, designed the first electronic perceptron machine. Okay? What he did was, for the physicists in the house, he just connected a bunch of wires, transistors, and all that stuff to represent something like this. Okay? He put it together, and that became the first hardware-based algorithm, okay, to learn a pattern. Okay? That was this guy. Now, since then, of course, computers came. Okay? We are now able to replicate this whole thing, all right, with a computer program, some of which are the likes that you're rating. Okay? And from that point, we've had different trends. You can go through this up until now. All right? So you agree with me that we don't build this hardware anymore. Okay? But instead, we can replicate these things as simple code in a program to achieve the exact same result. Okay? So I'm going to just give you a brief of this perceptron model. Like I said, it is just multiplication of two vectors. Okay? So this is the input. All right? This could be anything, image, audio, anything, you convert it into numbers. All right? So for the sake of demonstration, I just represented them as x1, x2, x3. They are n-dimensional inputs. All right? Similarly, okay, these lines, they represent parameters of a vector, points in a vector. Okay? So each of them multiplies their corresponding inputs. So it's like I said, they multiply everything here with everything here. That's what it is. That's what this diagram is. Okay? If you multiply everything, you get a number. Okay? Which could be high or low. All right? You can decide to squash that number. All right? Which is called this application function. Are you following? Once you squash it, you get an output. So the goal of learning now becomes, how do you adjust these variables? Okay? So that it matches the pattern that you desire. That's the goal. All right? This is artificial intelligence, artificial neural network. Okay? We can take it further. Each of these guys here is called a neuron. We can start them up. 1 neuron, 2 neuron. I mean, we can now do complex designs. Okay? This is still the same input. Are you following? Now, because we have multiple neurons, it's no longer a vector, but a matrix. Are you following? So you're now doing matrix multiplication. We're now multiplying this with that. Is this clear? We still squash it with the activation function. That gives us an output. This is artificial neural network. Is this clear? Okay? If we now want to go crazy, all right, we can decide to stack many neurons in different layers. And that, my dear, is deep learning. Okay? All right? So we can now decide to stack it as deep as we can. And that is deep learning. Okay? When next we see, we're going to continue with this concept. Have a good day.